Chapter 6 starts off requiring us to factor polynomials. If you're asked to factor, the operation between your factors must be entirely multiplication. In this section, we will be factoring out the greatest common factor of a polynomial and factor by grouping. The greatest common factor is the most that is common to all of the terms that make up your polynomial. If we are factoring, we are doing the opposite of the distributive property, so therefore we can check by distributing. The greatest common factor is the largest number that divides evenly into a group of numbers. Here all factors of 24, 36, and 72 are listed. 12 is the largest number that divides evenly into all three numbers. When you look for the greatest common factor of a polynomial, we will do it for the coefficients, these are the constant factors, as well as for the variables. Here are the formal steps in finding the greatest common factor. Again, we will find the greatest common factor of the constants and then again of the variable part. You may not always need the formal steps in finding the greatest common factor of the constant. If necessary, prime factorize the constants, then select all different primes seen between all of the factorizations. Make sure to select the most common to all of the terms. As for the variables, if a variable is seen in all of the terms, it will be a part of the greatest common factor. Select the smallest exponent on that variable, since this is the most that can be factored out of all of the terms. Since 60, 90, and 150 are fairly large, let's prime factorize the coefficients. If necessary, use the factor tree to help with your factorizations. We see 1, 2, 1, 3, and 1, 5 common to all factorizations. Only a's and b's are common to all three terms. The smallest exponents on these variables is selected for the greatest common factor. Here's our next example. My focus is on the 24, and I know 8 times 3 is 24. 8 divides evenly into 80 and 120, but 3 will not. Therefore, 8 is the coefficient of the greatest common factor. If you need to completely prime factorize the coefficients, again, this is always your options. As for the variables, only y and z are common to all three terms. The smallest exponents on those factors is 1. Here are the formal steps in factoring out the greatest common factor of a polynomial. Recall that this is going to be the opposite process of distributing. Therefore, we will be able to distribute to check. We start with the greatest common factor of the coefficients. Since the smallest coefficient, 4, divides into the other coefficients, it will make up the constant factor of the greatest common factor. X is not in every term, therefore it cannot be factored out. After factoring out the greatest common factor 4, we now ask ourselves, what times 4 will give us the 4 original terms back? Remember, you can distribute to check. Let's move on. Here's an example that doesn't seem to have a greatest common factor. Therefore, we may assume that it's not factorable. But if we look off to the left-hand corner and FOIL, we get back what we started. Therefore, it is factorable. We're now moving on to factor by grouping. In order to be factorable by grouping, you must have 4 terms. We then group the first 2 and the last 2, factoring out the greatest common factors out of these pairs. If the resulting binomials are common, it is factored out, and we finish off our factor by grouping process. To start, there's no greatest common factor of all 4 terms. So moving on to step 2, group first 2 and last 2, factoring out greatest common factor. After step 2, you will know if it's factorable by grouping. Look closely at the binomial factors. They are the same and can be factored out. To check, FOIL, see if you get back the original polynomial. Here's a second example. We need to start focusing on the sign pattern. Notice how the first 2 terms have the same sign pattern as the last 2 terms. The sign pattern is the same for first and last 2 terms, so we're not going to have any problems on this one. After factoring out the greatest common factor of the first and the last two terms, we see that the binomial is the same. Factor out the common binomial to finish off the factoring. Again, to check, FOIL. For this example, there is a greatest common factor of all four terms. Start by factoring out the 3. Before we group first and last two terms, focus on the sign pattern. The first two terms are both positive and the last two are negative. Therefore, the sign patterns are opposite. We need to somehow account for this. In order to get the sign patterns the same, we will factor out a negative with the greatest common factor of the second two terms. Note the sign switch of the last two terms after that negative is factored out. Now we go on to factor out the common factor from the first two and the last two terms. The binomials are the same signs, so now factor out that common binomial to finish. Again, to check, FOIL first, and see if you get back where you started. Thank you.